Good morning, everyone, and here we are once again, jumping right back into it, working on WalkTheWeb, which is a 3D CMS. It's kind of like a WordPress, but designed around gaming engine and adding gaming components. So we're setting it up to work with plugins. We're setting it up to be able to connect internet sites and pull things from one site to another. And that's about it. So jumping right in, today I'm working on trying to see if I can get the avatar to actually hold things in their hands. But I want to create a way that makes it real easy to just say, put this in that hand, you just parent it there, and you're ready to go. So we're going to do a little bit of stuff and see if we can't make it simple. So let's jump in and see what we get. Okay. Okay, so jumping in, one of the things I want to try first is I want to see when I create the mesh. Right now I only have one avatar in my scene. It's my avatar looking at a self view. I want to see, based on what I'm loading, in fact, let me file up, I'm going to get the, just loading up the Malcolm character, which is the avatar that I'm currently using. I'm going to want to modify it and do some things with it as I go. So just wanted to make sure I have it ready here. Okay, and one of the things about it is there's a number of different places. I want to get a certain part. And I want to get the, let's see, first of all, I'm going to say, I'm just trying to locate which piece I need first. So let's look for the right hand. And then we're going to see if we can parent a mesh to that hand by default. We're just building the gap to what we're doing. Actually, that's the bones. Let me think about this. I want to see if, let me connect it to tops. That would work. If the, let's see, mesh name, if mesh name equals tops, that's how I spelled it and everything else, then I want to, we're just going to see if we actually, if we hit this and only hit it once. I don't want to load it 10 times. But let's see what happens. Okay, we're getting this in place. I know, I feel like I'm repeating a little bit. Okay. Have a little less coffee this morning. Yeah, that's it. And as I say that, I sip on coffee. Okay, so it loaded once. It found tops, which will be his shirt. And to start with, when it finds this, I want to add a basic mold, which is going to be just a cube. We're going to say add scaling should be 111. I don't think we'll have a problem with that, but I'm going to start by creating a cube. And then I want to parent it to the top. And what I'm really checking to see is when I parent something, a mold, to that mold, does it take on the animation and does it move with it? If that's the case, then I can do something with the hand, create a right and left hand where you would grab something, and then I can make it where we can easily just parent to it and go. So this is going to be var we're going to call it right hand. Oops. Wow. Kind of got right name in my mind when I said that. So right hand. I'm going to leave it with just calling it right hand for now. We'll come up with the proper name later on. And then right hand, we're going to scale it to 1 by 1 by 1. And it may end up very small. I'm just warning you because technically I shrunk this avatar And because I shrunk the avatar, if it stays proportional, it just may be, if we parent to that, it should stay 1-to-1 to that object. I don't know. We may be shrinking it very, very tiny. So I just want to see, first of all, if I can create this. And then, dang, I did it again. Right hand dot parent equals, and we're going to call it this mesh, which is the actual top. I may have to make it bigger to see it because if it's real tiny, it's going to be wrapped up inside the body. But let's see if by parenting it there, if we actually place a cube in him first of all. And what size? No. Side orientation is not defined. Okay, hang on. Side orientation does not need to be set here because default orientation is exactly what we're using anyway. So we don't have to worry about that. Let's reload. And here we go. Test happened. Okay, as I suspected, we parented it to it, and basically it became extremely small. Let's go 50. Trust me, this isn't too big. I don't think it is. We're going to find out. It should be a 2x2x2 if I calculated right in my mind, because we did 0.04, which is basically, there's the box, and is it parented to it? No, it isn't. It is not moving. It's parented to the ground, not the top. Oh, the top position, that's not what's moving. Huh, that's what I was afraid of. The box is not moving. Yeah, we have a problem. It's the bone that we need, like I thought before. The problem with that is the bones for this guy are actually still not scaled right, and that's going to be an issue. If we add a mesh, it has to be transformed. Transformations take it all to 0, 0, 0 of his character, which puts it at the base of his feet and not subject to the animation that applies to that animation. Huh, yeah, that's going to be an issue. The only way to do this is connecting it to the hand. But as you can see right here, if I go to the skeleton and we tell it to go here, if the mesh name here, which is the skeleton name, is, let me grab that name. It is this, then, and we should be that should give us the right, well, that's the skeleton. These are the bones. It needs to be bone.name equals that. Then create a box and parent it to that. Now here's the problem. What you're going to see is this box is going to be floating a mile above his head. Yeah. Okay, so we're creating the guy. And no, we didn't find that box. Okay, hang on. We didn't get this part. Oh, I put it inside of a piece here. We are needing it to be here. We don't want it to be within that. It'll never find it. Okay, so that should find it. And of course, now we deal with the issue about the transformation of the actual item. Which means if I look up, and don't look directly at his head, notice the box up there is floating, and it's in proportion to the position of him. It is moving as if it was in his hand and he was 25 times larger. Yep, that's the problem I'm running into. So how do we do that? I tried to scale, as you can see from this, I tried to scale the parent bone. I never found that. Let's see what happens if I do this. I don't think this is going to do it. In fact, it's probably going to error, but it doesn't hurt to try. So we start out here. We're in the character, and then it releases it, and we look up, and there's the box up there still. So it didn't error, but it also did not scale the actual animations. I think there's only one way around this, and it has to scale before it gets brought into Babylon. When I bring a character in here, and he's full size like that, scale avatar, he's not scaling the bones. Okay, well, I'm going to have to still come up with another way of doing this. I know, they're talking about accuracy. Accuracy is not exactly what I'm having a problem with. I'm having a problem with scale, pride, or export. You know what I could do is I can set scale on every bone. If the bone is not null, then we set the scale to 1/400th. I'm just grasping at straws right now. This is something that I've needed to fix, and I'm still experimenting, trying to find a way to fix it. It's creating the avatar, and there he is. And then I do this, which means if we back up far enough, there's the box. See, it didn't scale it. It doesn't scale the skeleton. Can I scale the skeleton as a whole? No. I think what's happening is the animations and animation transformations are staying the full size, which means when I connect to a particular bone, it's at the scale that had happened when they were written. Yeah, because it's giving positions of everything, not... Yeah. Yep, we got an issue with that. That's not going to work. Okay, well, it was worth another try. I've been working on this one for a while, and I guess I'll be working on it for a while longer. But there's another couple things we need to do anyway before we can finish out that setup. So we'll do some more work on it, see if we can't figure out something. Yeah, without bringing in something that doesn't transform as a mesh, or without, scaling before we get here. The problem is, I tried to scale the avatar before bringing them in by scaling the first bone, which somebody recommended, and that still has its issues. The animations all looked off. Yeah, we just aren't getting it there. Let me play around with that for just a couple minutes. One of the things they recommended was to scale the avatar. Instead of scaling the avatar, scale the first bone, which everything's parented to. But see, the problem I'm having is I'm not able to scale this first bone. It scales the armature. Yeah, I just don't know how to do it yet. Yeah, see, none of that stuff. This is wrong. A lot of people, a lot of people have dealt with this, and I've seen things, but of course it all depends on the dates of when they happened. I'm not there yet. Okay, got to do some more research. We're just not ready to solve that problem. Okay, so the next thing that I'm working on, and there's multiple pieces here. One of them is angle to target. I'm trying to design this to automatically know where we're at, and also my angle. And if I want to match an angle to the target, and I'm writing a bunch of functions that we can use from within animations to help move our character around. And to do that, I'm writing them in common, but I want to, this one's going to calculate the angle to the target, which is no problem. We have that one in place now. I've added two menu items for testing. Angle to target, which is from any box, and then my angle to target, which calculates that. I want to calculate, we're creating some useful functions that everybody can use when you are working with stuff. So the next one that I want to test is I want to create I want to rotate to target. Rotate to target, which means after we find the angle, we need to be able to rotate our direction towards that target, and we're going to give it an increment so that we can animate it and actually bring it in from this thing. So the first thing we do is we figure out the angle to the target, and then we have to decide, first of all, here we have to decide 1 degree change. And I want to be able to do this so that I can rotate anything. So if I'm rotating a box to the thing, I can rotate a box to it. If wait a minute. First thing I need to know is what is the angle of the source that I want to rotate. Var source degrees, which is going to be y, is equal to this dot, well, let's see, rotation y, and that's going to be, I have a function that get degrees, and then here we're going to say if source degrees is less than line angle degrees, then, source with two O's. Okay, there we go. Source degrees. If it's less than it, else. Okay, so we'll have another condition. If else if. Okay, if this condition, which is source degrees, oops. Let's get source degrees. Oh, see, this is where we run into trouble again. Source degrees. Nope, that's not going to work. It is, if source degrees is less than line angle degrees, that's not going to be a perfect thing, because if you are at 2 degrees and it's at 380, 340, then basically you're going to have to turn left, and it's not going to know that by this statement. We'll do the basics first here. If source degrees actually, there is a way of doing this. If source degrees plus 360 is less than line angle degrees plus 360, that's moving both angles above 360, then it'll always be less or greater than, depending what it is. There's a way to do it. Okay, so then if that's the case, if it's less than it, then we need to grow, which means z source equals rotation y equals, later on we'll have to have a three-dimensional version of this. That'll be interesting. But for now, I'm just trying to make them face the target. We're going to use these for the golf game. That's why I'm doing them, by the way. I need to fix a couple things so we can do this and make it all work. Okay, so source rotation equals WTW, get radians of, and then this is going to be source degrees, which is the original source that we have, plus increment. We should call that, instead of just increment, we should call it degrees. Degree increment. So we know that it's not radians. That way it makes it easy to not mess up later on. Okay, and we're going to say equals this plus that, else this minus the degrees here. And let's see what that does. Every time we click it, rotate to target, let's first of all make sure that we didn't use that name anywhere. Nope, it's unique. Let's make a menu item. Okay, let's do 2 of them. And this particular one is going to be rotate to target. Copy that, copy that. And put that there. And finally, that's going to be okay, that's going to be 2 and 3. Just keep my menu options in order. And finally, over here, that's grabbing the mold, and this one's grabbing the avatar. But this one here should be the name of the function here. And for now, we're going to add an increment of 1. We're going to change 1 degree at a time and just see what happens. We know that at the last move it's going to be less than 1 degree or something. That's all going to be fine, but we're going to start with this and see what happens. Load that up. This, that's a degree to the target. Okay, so now if I say angle to target, oh, I didn't change the words on that. Oh, cannot read property Y of undefined. Okay. Let's see what we did. First of all, I'll fix this while we're here. This one is not angle to target, rotate to target. And my rotate to target. Okay, now here, what did we do wrong? Source is that object. We already know that it's not null. Rotation Y. What else did I use a Y on? Source name. Oh, that's why. Degrees of source rotation to Y. That'll do it. Let's refresh that and give it a shot. I just want to see if this thing's actually going to rotate towards the target so it looks like it's facing it. And then we're going to try it with our avatar and see if it makes a change. Okay, so rotate to target. It's turning towards it. And when it faces that direction, it should come back the other direction or like gravitate between the two. Let's see. Yep, there it is. There it is. So it does rotate to the target and stop at the target. Okay, so far so good on that one. Now let's put the avatar camera back in the avatar. Let's go back to a front view. Follow camera, just so we can kind of see where he's at. And now we're going to tell him to rotate to that target right there. My rotate to target, and oh, going the wrong direction. See, this is where I get in trouble every time I'm trying to work with it. I have a feeling that I am going to completely be 180 degrees off. And that is definitely an issue with all of these calculations. I don't want to... See, this is where I'm going to get in trouble every single time I'm working with this. So I need to fix so that it knows what direction to do. And it kept on going. It did not stop. See, there's a problem. It does not know. Rotation's always 0. There's our issue. Oh, wait, it's 90 degrees. It is at negative 90 degrees. Figure that one out. Okay. This is where we're going to have to fix this. And I really... I'm nervous about fixing this one because if I tweak this, it's going to change a lot. But if I don't fix it, we're going to have avatar issues from here on forward. The problem is this. When I calculate the position to the point, I don't want to have to make a correction of if it's the avatar or not. The avatar itself, when we create it, we have a number of things. The first thing we create is this is the avatar and it is a box. That is going to choose the direction that you're facing. Now, it should be facing the target. That's the point. The problem is, okay, I'm not worried that it went the wrong way around. We'll work on that. That's just something I still have to solve. But what I do have to do here, is that this This direction here, when I tell it to face something, it is not facing the direction that we believe it is. Now, when I change this, it's going to change everywhere that we tell it to save a position in rotation. It's going to rotate us off target for every single thing we've built. So anytime I tell it to start at this position and save this position, the coordinates are correct and the rotation's correct, but it's not correct for where we're actually facing. So here's the deal. The quick solution is this box knows what direction it's going. It has not been rotated, or has it? The avatar name, the avatar, I know this is going to, if I search for avatar, I'm going to find 500, probably 1,000 different references to avatar. If I take and I make a correction, for example, there is a scale. This is where I'm deciding the scale of how big to make the avatar so that the box where he's at is always 111, but the avatar can be scaled differently. That's also the part that happens to be throwing off the scaling of the, all the movement. If, here's my concern. If I take this avatar scale and rotation dot y equals dot, this is dangerous, get radians of -90. Since it's parented directly to that and we rotate it, this will move everything that is based on it 90 degrees to that direction. That also means things like the camera that is parented are not facing the direction as that. Excuse me, and also the center is the avatar. Those couple points will also have to be rotated, otherwise follow views, everything will be off. So I need to do the camera and the center point to be facing the same direction for me to be able to calculate things in relation to it. I know that I'm opening up a can of worms, but technically if I fix this, we won't have a problem with it from here on out. Yeah, okay. Okay, so here's the trick about this one. We have the guy. Notice he's not facing the target. Oh, see, look. We are off for every direction now. Gosh, that's going to be interesting. Rotate to target. Oops. And when I tell it to rotate, am I the right direction or am I 90 degrees off? That's the first part I need to check. But I think if I get all these straight, it's going to be a lot easier to work with in the past or in the future. Gosh, it's going to make me go 90 degrees out of phase the wrong direction. Okay, we did that last time, so I know it's turning the wrong direction for what we need to do. And I could go 5 degrees at a time instead of 1 next time just to make this easier, but we're getting there, we're getting there. I'm almost there, almost there. I want to see if he stops in the direction of the target. That's our first piece. And does he stop right there? Yes, he does. So if we want him facing the target and have full control where we tell it an angle and he automatically goes the right direction, which would be a bonus, then we need to do exactly that. Let me determine. First of all, we have to fix every one of this. This is a core issue that needs to be addressed, and that's why I'm working on these so that I can fix them and we can use them just once and have everything going the right direction. Right now, that's what keeps on throwing me off. Every time I'm working on the project, all of a sudden I'll try to rotate to a certain angle, and it turns out that it's backwards and off and throwing the wrong direction and everything else. So I'm just trying to create something. Let's check this. I know another way to check something. I'm going to create one more box, and I'm going to put it directly in front of this box, and I'm going to make it so it's shown at the moment. So let's create, I'm going to create one more box. We're going to make it a test box. Instead of being hidden, we're going to say color, which will automatically make it white. Alpha is 1, so we can see it. It's not transparent. Is pickable is false. Avatar parent is there. Scaling is, okay, we don't need to scale it. And we're not going to rotate it. But I do want to make sure, see, this is a good way of checking the coordinate system to make sure that we're putting this in the right place. This is going to be test. Make sure we're doing that to test, avatar test. This should end up on the ground level, a box directly in front of our avatar. Position equals, it's parented to the avatar, which is that first box, and this position should be Z. This is going to be dangerous. Position Z. Oops. Let's go 3, just so it's in front of it. And we're going to call position Y 0 and position X 0. Technically, Z should be forward and backwards, Y is up, and X is left and right in a perfect world. Let's see if that box gets created in the right place. That's our first test. Because if it's not in the right place, then it's not going to matter anyway. Specular of undefined. Whoops. What did I do? We do not. Avatar def, avatar name. Okay. Ba-da-bum-bum. Should be like that technically, and this should be like this technically, but that shouldn't give me that error. Avatar test, blah, blah. I don't see a reason why that shouldn't work. What did I mess up? Basic coverings, add coloring cover, cannot read property. Specular of undefined. Add coloring color. And blah, 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 blah. Oh, there's no material. Well, that's creating the material. Specular of undefined. Let's try that. I did change something. I just want to see if it's going to create. Oh, come on already. Let me do this another way. Material equals. We don't need to do all that. Just create a standard material. It's easy to do. We have them all right under coverings, basic covering, and what I'm going to tell it is color covering equals new standard material, and I'm not even going to set any colors or anything. I'm just going to do that, and avatar name plus test, just so that we don't name it the same as some other covering. That should give us something. All I'm trying to do is a quick down and dirty box that I'm going to delete afterwards anyway. I just want to know that I'm facing the right direction. So there's a box right there. Is it in front of my character? No, it's off to the left. Okay, so that's not the direction I'm facing. Okay, is the avatar turned? The easiest way I know what I can do. Let's see here. Every time I click that button, what I want to know is WTW log, and I'm going to say source rotation equals plus WTW dot get degrees of the source rotation. So I want to know where it's at because I need to know where 0 is, and whatever direction 0 is, we're going to make a lot of, we're making this adjustment to fix a lot of things. This will make it easier for everyone who comes afterward to code against this system, because if it turns out that, hey, if you rotate a box, it faces this way, but if you rotate your avatar, he's 90 degrees out of phase, you're going to have an issue everything you try to do. So what I want to do is I want to see C266. 264, okay, we're going that way around. It's the wrong direction to go. It's the wrong direction to go, and we'll work on that later, but I do want to make this work. I need to see that, see, here's the deal. I want to know what direction 0 is, because I think 0 to him is different than 0. See, we're not going to get there. We were closer to 90 before. We're going to go to 16. We're not going to get to 0 degrees. He is facing 0 right now. So I have him facing the right direction. The thing is, I think I'm off in the... Okay, so going forward from him is X direction. X is forward and backwards. Z is left and right. That's what I'm missing in my head, I guess. Okay, so basic avatars. Instead of that, I want this to be, oops, 3 positive and 0 to the XY. I want to see if the positive direction is in front of him. Let's double check that first. Then we can, at least we'll know what direction is forward. Because according to this, that should be forward now. And the box is directly in front of him. Okay, so what we've learned is, first of all, we're turning the wrong direction to get to the point, which is fine. We can calculate that. What I need to do is You know what? I'm going to take a 1 minute break real quick, fill my cup, and then I'm going to come back and we're going to decide once and for all how we're angling the avatar, and then we're going to go fix all of his movements, and we're going to get this all going the right direction so that he is naturally the same direction coordinate system as every box that we put in the screen. Otherwise, we are definitely dealing with some other issues that are going to be a major problem. So we're going to realign everything, make sure it's all facing the right direction, and then we're going to fix all the animations that go along with it so that they happen the right way. Oh, the animations happened. Oh no, the animations are working right. They're just not. The movement of them aren't working. Okay, we can fix that. We're going to fix that because that's the problem that we have. We're going to write a formula. We're going to get this all straightened out, and we will definitely write some functions that make this real easy that we can use at any point in time for our movements and everything else. But this is going to fix a major problem that I've been dealing with. Notice how, since it was 90 degrees off, that always messed up everything we were doing with our avatars. The only way to not correct that rotation would be if we rotated and transformed it in the Babylon file. Don't want to go there at this moment. It's possible, but then all we have to do is make sure that the avatar is facing forward compared to the box, which, as you saw, we rotated it that easy. But now with the movement, I want it to be in this direction so that we know which way we're going, and we can always correct the avatar. If somebody custom builds an avatar, we're going to allow them to rotate it and scale it, and then it works from there. That's just the way we need to be able to make it work. Okay, with that said, we're heading in the right direction, and I'm going to take a couple minute break real quick, and then I'll be right back. I'm back. No. Okay, here we go. Back into it. Okay, so today fixing some things. What we have is right now this guy was out of phase. He wasn't facing forward, and so because it was a 90-degree off from the import of the avatar, it ended up being a problem because every time I calculated angles, I was 90 degrees off. So I kept on having to write in all these calculations and corrections to his angles. Second, I started doing the mini golf game. I'd calculate an angle to a target, and next thing you know, I'd rotate to it and he'd be facing the wrong direction. And because of that, it just was becoming more and more trouble than it was worth. So the best thing I could do was to actually take this and fix it based on the coordinate system. Make sure that when we rotate a box, it knew which direction was its face, and then make sure that he can rotate to whatever direction he needs to be also. So in this case, what we have is, now see, I'm turning the wrong direction, which is also an issue. I'm telling him to rotate that way, which we don't want to do. Let's fix some rotation here. I'm going to leave the test box there for the moment because it helps us decide that we're going forward and stuff. And then we got to go fix all the animations. So we've got some little bit of homework here to fix. First thing is that calculation right there didn't work. If the source degrees, which means the angle that it is facing, is less than the line angle degrees and source degrees is greater than, I think this is going to get us in the right place, line angle degrees minus 180. That should account for if it's like a 2% and, well, see, no, if you're going over there. Just straightening out some math. It's been a lot of years, but I've done math before. I went all the way through calculus in school, went through calculus in college and everything. But of course, that was a number of years ago. And of course, math in my brain didn't. Well, I was having this trouble. I was trying to get these things. Yeah, you know it. I was trying to rotate him for the golf game. And what was happening is I would figure out the angle to the target and I'd go, okay, rotate to that angle. And he'd be facing 90 degrees out of phase. So I went through, I set him and I put a box directly in front of him. And that's what I added right here, was just a test box to put it directly in front of him and show it. Then what happened is whenever I rotate this position, which is your avatar itself, which is the bottom box underneath your character, and I would tell it to match a target to that angle, for example, then what was happening is it was phased out by 90 degrees. So I figured that out. I rotated him, but now, of course, watch this. When I tell it to walk forward, let me get into the character first. And when I tell it to walk forward, I'm moving sideways while walking forward. So basically, those 90 degrees have to be applied to every single calculation I did for the movements of the avatars. So fun, but I can get it done here. And then, yeah. But the thing was, the correction was worth it because the problem I was having is, for example, this box down here is, right now, is rotated 0 degrees. And what happens is, when I change that, it's facing 0 compared to this angle right here. So if I calculate the angle it needs to go to, oops, I didn't mean to hit that. I meant to hit this. If I calculate the angle here, and it's going to reload my page. So when I calculate from this piece, I'm going to back off of it so we can see. When I calculate from here to there, and it's facing forward here, and I say angle to target, it draws a line and it knows it's 45 degrees. Okay, makes sense. And if I rotate to target, it takes the top of the box, is this side right here, and I rotate to target. I'm going 1 degree at a time just so I can kind of watch it happen. And as I go, it finds that facing the target, and then it pivots back and forth because it's like less than or greater than, and it knows that that is the target in that direction. So this is the face. It was going 0 before, and now it's going that direction. Okay, makes sense. We're good with knowing that. But when I took him and moved him, first of all, my angle to target was 16 degrees, which, okay, that's 45 degrees, this is 16. That still makes sense. I'm at a lesser angle than that. And when I rotate to target, first of all, it went the wrong direction. That's something I'm going to work on fixing right now. But when it faced it, it wasn't facing the target. It was actually 90 degrees off. But now, when I go, it does face the target. I just need to, I could automate this so it just goes to the target. I could do a window interval just to do it, but for testing right now. But the whole idea is that, yes, it does go there, and yes, it does stop. So now that I know he is actually facing that direction, that is the box underneath him, now that I have that orientation correct, then now when I go ahead and I hit the target and I'm aiming at it, it rotates back and forth, and he is facing the same target. So I'm using the same coordinate system as that. Before, with the box underneath was facing this way, and I'd say, hey, I'm facing right at it, avatar is pointed this way. So now that I've rotated him to match the box, now I just have to straighten out all the other coordinates that are related to it. So first things first, let's make this turn the right direction. I have to think about this. There's a couple different ways to figure out if you're going positive or negative. Let's do var direction equals 1. And then we will do z source rotation equals this. And we're going to tell it to do that. And this is going to be the degrees times the direction. So if I make the direction negative, it'll go the negative direction, just like that. Okay, so then I don't need that. Now I just have to decide, when do I go a positive 1, when do I go a negative 1? So positive 1, first of all, let me figure out negative 1 first. If source degrees, which is the angle I'm currently facing, is greater than, it's probably the easiest way to do it, is greater than the line angle degrees, and source degrees is less than line angle degrees plus 180, then direction should be negative. -1. Let's see if that solved it. By doing a positive, I get myself out of positive negative real quick. But see, the problem is when you cross from, let's say, see, this is where it's going to fail. If source degrees that's the problem of going across 0. So you have a 360 is 0, and so 379 would be greater than, but then you want to turn the other direction. That's where I'm going to get myself in trouble with doing this calculation. I know I am. I've done this before. Okay. And let's see here. I just want to make sure from the start he turns the correct direction. That's all I'm trying to do at this moment. First of all, let's take the avatar. Let's take the little box. Let's make sure that still turns the right direction. And we click rotate to target. Okay, so it's still, oops, rotate to target. It's still turning the right direction. And when it passes it, it goes back and forth, and it knows it's going between 45 and 45. Okay, so that takes care of it for that. Let's see what direction he wants to turn. Yes, he's turning the right direction. Okay. That's good. Now, just to do it, well, we'll have to fix a bunch of stuff there. Okay. Actually, he should... When we get there, we might as well just get there. I want to make sure he's rotating back and forth so that he knows not to pass it up. We'll have to check some more angles and make sure that we're catching everything. Because there's going to be a time when it's a little past it, which means the angle to it will be a negative. I want to make sure those all work. Okay, so we have that. And we may have to figure out if this value is greater than 0, less than 0, blah, 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 and come up with some more pieces in between here, and I'm almost suspecting we do. So then, the next piece after that is we need this. When we walk forward, for example, on walk, we figure out the direction here, and that's where we're getting in trouble because this is not the correct direction. That's a vector. I'm using a vector. If that's a vector, we have those points which are there. So if I take this, first thing I want to do is I need a way to track this. So what I'm going to do is I'm going to add, on walk, I'm going to add this here. I want it to be some different, so I'm going to use a sphere. I'm going to set diameter equals 1. I think that's how to do a sphere. That's why I have this open still. Cone sphere is create sphere segments. So here we go. We need segments, diameter. I don't care about the rest of that. That one's going to be required. Segments, let's go 12, just so we have something. And it's going to be, do we have avatar name here? Do we? No, we don't. It would be avatar.avatar name, I believe. I think it's avatar.name. We're going to find out here very quickly if I'm wrong. Avatar.name. And we'll call this test 2, just so that it's not the same object as the other one. If it's that, if it's null, it's going to create it, and then we're going to tell it to position. No matter what, we're going to tell it to position on every step. It already is created. And avatar test 2. Just so we have something here. And it's going to be, position is going to be this. See, stride is a -15. We're totally backwards wrong. I don't want to include stride. I'm going to make it be parse this. Copy that to here for x value, and the y value is parse float this times stride. We're going to say stride equals 1 just so we can make it stay in our scene. This will give us enough of a hint telling us which direction it's going, and we should be able to take it from there. So yeah, that's kind of how we're coming about this. Let's see if that creates sine and cosine. Let's see if that puts it in the right place, which would be the direction we're going to walk, which in this case should be forward. We could do this times 3. Oh, cool. Yeah, I've been there too. Yeah. Glad I'm not with that one now, but I've had that one before, so I totally get it. Okay, so this is going to be, I'm multiplying it times 3 just so that it's not directly on our character. Now let's see if this works. Okay. Okay, when I tell it to walk, yeah, that's when it's going to create it. Let me put the avatar into this, and when I tell it to walk, I don't see that ball anywhere. Okay, let's look away. There it is behind him. Okay, it's 180 degrees off of where he's facing. But then the movement isn't happening in that direction anyway. So there's, oh, it's a negative number. Well, that still doesn't make a heck of a lot of sense. The direction, stride was going negative, because the weight, those are all positive. Stride was a -15, which makes it backwards to begin with. That's why we're fixing these, by the way. Okay, so if I make this a positive number, then if I take this direction, just out of curiosity, when I move the avatar, I want to make sure that's moving with me. So I'm going to rotate this direction, and I want to just make sure that it moved with me. Did it stay behind me? Yes, it did. Okay, that's a good sign. It means it is a constant direction, just not the right direction. So the first thing we need to do is see if we can create the sphere in the right place. I'm going to make this a negative number for the rotation. By changing both numbers to negative, that should, instead of, it would go. Okay, so I think by changing both those numbers to negative, we should get him in the right quadrant, and it should be something directly in front of him. We're going to find out if I'm right. Told you it's a math day. Now it's not going to appear until I start to walk, so the first thing I have to do is actually tell it to walk here. So walking forward. Oh, it's going to be right in front. It's going to be right inside of that box there if it's all correct. I can kind of see it. You see when I went sideways, it's a little off from where it's sitting. I can kind of see it on the left side of it there maybe. Let's double check and see, is there any other circle anywhere? Nope, but you can kind of see it there. It is in that. It should have been the same position that he's facing, because I don't know why they would be actually off by that degree. I think that's just one of those where it rounded the number or something to calculate it. We'll do this just to do it. 3.5 and make that a 3.5, just so it's not in the same place. And I mean, it's going to be close enough for us to work with, knowing that that's the direction he's actually traveling in. So taking this, here he is. Go back to our avatar, make it walk forward, and now we'll fix the animation. See, like I said, we'll fix the direction of these movements. That's not the concern at the moment. Actually, it is. That's what we're fixing. Okay, so now, but see, the ball is next to him. Oops, that's bad. I didn't mean to do that. Avatar focus. If I rotate, the ball stays on the side of him. That's not what we wanted. Okay, that's why I'm fixing this. We definitely have the wrong. We have the wrong coordinates here. We're gonna try. If I'm not mistaken, you can do cosine and sine over here, or is it? Would it be just as simple to do rotation plus 180 degrees? Not necessarily. Yeah. I know it's going to be one of these, and it could be positive and negative are turned around. We're going to find out right now if they're turned around or not. Takes a minute to get all these straight. Okay, make him appear. There he is. And yep, it's back to the side again. Second I went forward, it's on that side. That is not correct. What do I need to do to get the direction in front of me? That's why I have to do this stuff. Okay, find the coordinates of point on line. Okay, sure. Let's. I know. Angle 0. That would be the angle of that. Wait a minute. That should actually be a lot easier than I'm making it. The direction I'm going. Now that's finding it by a point. Let's say I have 2 points. Direction. Okay, I asked the wrong question there. By the way, did you get a domain name? Do you have a domain name, or do you want me to create you a site using one of my domain names? Let's see. Get point. Figure out point Y by angle and distance. That's what I want. Math cosine of 10 degrees. No, that's degrees. Changing to radians. So cosine of the radians. Y is at 207, so x is this degrees. X is cosine, y is sine. Okay, that's what I was trying to confirm. X is cosine, y is sine. And that's the avatar rotation, which should be the overall rotation of the object. So y is the position of that box coming up on the side instead of in front of. See, this is why I ran into this issue. There's a negative involved. I will try this one first, but I have a feeling it could be the other one. There's a reason. But see, 90 degrees, 0 going forward or 0 going backwards, I'm not going to hit it this way. That's not going to be right. See, it moved it to the other side. That doesn't make it right. I do not know why. The only thing that works is putting sine there and cosine here. But why did that? Well, there's an easy way to do this. Let me find out what I'm actually dealing with here. X equals wait a minute, there's an easier way. We're dealing with world coordinates. And if I calculate them based on the guy, that's always world coordinates. That shouldn't be an issue. Okay, just thinking through this stuff. Rotation. That's not going to tell me anything, even if I look at it and know what it is. At whatever degrees, direction, why does it have to do with stride? Oh, if it was forward or backwards. That wasn't a big deal. Okay, we're going to do this another way, and I'm going to make a function for get direction just so that anybody can use the function and we'll never have to, we won't have to keep writing it. Okay, this is going to be called get direction vector. And source name, and I'm going to use its own angle based on that. So I'm going to take off target. I want to I want to use well, we're going to figure this out. I don't need to draw a line. Well, you know what? I can draw the line afterwards to see if I'm even right. That would help. Get radians, -8tan. That's doing the opposite. That's taking two positions and doing it that way. That's not going to help us here at all. Okay. Well, get direction vector, and I'm going to add degree offset. If degree offset's blank, if degree offset doesn't get sent, then we're going to look forward. Degree offset is undefined, then it is degree offset equals 0. Then we're going to take the source. Source is not null. I don't want to get rid of all this stuff just yet, but we don't have a target because there is no target. We're going to make sure that we do this right so that every time I do a direction, I can say, hey, give me 90 degrees off this, and we can automatically know where we're looking. So the reason is because this direction is not only used for what direction you're going to walk or move, it's also used for detecting if something is coming up on it in a certain direction. So like if I'm walking up on steps or whatever, I can actually see that there's going to be a step there and make it step higher or whatever. So get direction vector is going to do technically what the core does at this point. So direction would be equals get direction vector, and it's going to automatically return the vector based on these points that we're going to create. If that makes any sense to you. Okay, so then what I want to do is I'm going to move this testing stuff over to this file I'm creating. I'm going to do that. Avatar name, I already know what the avatar name is. Well, you know what? We just need the avatar. This box is not going to be here when I'm done, so I'm just going to call it test2 for now. That way we'll delete it when we're done, but that'll help us test our point that we determine. And that's going to take care of covering for it. And we're going to parent it to the avatar, which we will have to define here for this piece to work. So we're going to make that. This is going to help us test the point as we're doing it. Actually, we don't need any of this. We're not going to test it that way. We can use a line. We're going to dispose of the line, then we're going to tell it to create the line based on this position that we're actually creating. We're creating a target position. So then it's going to draw a line to that target position based on whatever we calculate equals the target, the position. So we will call this position X, position Z, and we're going to get rid of the word target. So it's not going to be an object that way. Do we have any more target things here? No. Okay. Position X. Position X equals, we're just going to set them up here. And then position Y, or position Z, I mean. Position Z is equal to 0 just to start. And we're going to figure out what position that needs to be at based on our source. That's what's going to give us, because it's going to be the source, and then whatever degree angle from that, this gives us position. So we don't know the position of this object because that's where we're heading. Okay, no problem. Now we just need to calculate those positions, which over here we were doing this way. Move equals vector. Oh, sorry, wrong one. That is not the right one. We're going to fix all those because it's going to be based on the direction. So the direction is this. And we're going to it won't be null when we're done, so that's not going to stay that way. But for now, I just want to start with let's put this here so I have it, and we're going to tell it to return the direction from this function. Okay. And z direction is going to be this here, and rotation y, and this copy that. One more. Copy that as rotation Z, and then returning. We don't need stride, but we do need to parse these directions. So it'll be new Babylon 3. Well, let's just do it this way. Z direction equals new Babylon 3, and it will be position X, 0, and position Z. Okay, so that's going to return our direction, and we should be able to, the source name is going to be, instead of avatar, it is Z source, because it's going to be whatever rotation that particular item is. And then it's going to get rotated and brought back this way. Okay, so then all we have to do is get direction vector, and offset will be 0. And we place that here for the direction. And it will be WTW for the class, and then it'll be get direction vector source name, which now is going to be avatar, and degree offset. In this case, I want it to be 0. That's what we're aiming for, and that should be the direction of moving directly forward. That's the point we're trying to make. So from that, we should be able to come here, and now the line, it's going to draw the line based on what I do, which will give me a line to whatever position that these points are created, and it's going to update as I go. So we should get some type of feedback from here. I'm not worried about that angle so much because it should always be 0 if everything works right. Okay, so we won't need these calculations at the end. Well, That's going to tell us the angle to the points. We're going to leave those there for a minute. We're not going to need them at the moment, but we want to draw the line between those 2 points that are, oops, we have target. And this is going to be position X and position Z. Okay, so now we have from our source, which is our character in this case, it's avatar, and then it goes to the position that we're designing, which is here. Okay, that calculates the angle. We should be able to do that opposite. Okay, fine. But this should give us our position. That's the whole point, is whatever I change here, we should be getting what we need. So let's find out, first of all, what direction it thinks it points. Once we do, it should be pointing off to the right because we already knew we were off on our angle before. And this only happens when I actually point forward. You know what might help is switching to a scene camera, then we're a little bit above it. We won't have to keep changing it every time. And when I walk forward, first of all, I'm not moving. That's interesting. Cannot read property X of null. Set avatar movement. Let's find out. Avatar movement is... Wait a minute. Get direction vector was not where it aired out. Set avatar movement, cannot read property X of null. That should be here. Set avatar movement, cannot read property X of null, which means that this did not return a direction vector. How do I do a property X of null when there's no X value that I'm pulling? Where is X? I don't see it here. Just out of curiosity, let's make sure that it's happening somewhere in this area. Let's remark out from there to there. I believe that's going to be the case. Of course, it's going to try to figure out why it couldn't move that piece. But that part there doesn't have a value X of null. Okay, so I move on the screen, try to move forward. Okay, it's definitely happening in that section. The only thing we changed is the piece here, which gives us our direction. And it is bringing in the... Oh, it's not avatar, it's avatar name. That's where we're wrong. We're passing the avatar name and getting the other piece based on it. That's why. So if you take avatar, of course it doesn't have those pieces because that isn't the name of the avatar. So now, bring this on here. Okay, so that's the direction it thinks it's going, and if I rotate, oh, it rotated back to that spot. Nope, that's not right. It should always stay in relationship to him, and because that didn't happen, this direction, get direction vector, did not find... I should be drawing a line. The line should be from this position to this position. Oh, these positions are 0. If those positions are coming up 0, that would explain a lot. Because then if it's 0, 0, then of course that is where it's always going to run. sine that times 3.5, just so we're not working from 0 or 1. It'd be 1. We should be able to get this to work from the angle of the avatar. That's what I'm trying to do. See, it's drawing that angle, but as I rotate, it stays to 0, 0. Hey, wait a minute, it's not 0, 0. See, it's off-centered by 3.5. That's all that did. Yeah, I can make it. All I got to do is this. Walk straight to that direction, I can get closer. Okay, fine. Oh, but see, it switched. Yeah. Okay, that didn't do it. It centered the source. Source rotation, we should be getting... Let me make sure. Source name. The source is the avatar. I'm just making sure. Because if the source isn't the source name, then that would explain a lot. We should be getting the avatar name, and then we should be able to get a couple positions based on that. Positions should be related to... Oh. Position is going to be related to the source rotation. We forgot to add the position of the source. That's what's wrong. So position dot position x plus, and this would be z plus. We have to compensate for where our position is in relation to ourself. That's why it was always off-centered, because it was always the same position from the center of the object. Now it's going to be positioned from us. My rotation. It should automatically be there. So let's see, based on my rotation, first of all, is that position changing? Okay, we're going to find out here. I'm almost there. We're doing, it's on math day. Nobody likes math days. Okay, so when I walk forward, oops, come on. Okay, it is trying to stay to the left of me. That's why it's walking that way, because that's the way it's calculating right now. Okay, so let me check something. Let's do math cosine of get radians 0. I know that's still 0. And let's see what that is. I'm just checking something. And sine of same thing. Okay, one of these of angle 0 should be in front of me, because the angle Whichever one it is, that's the direction that we need to make the primary in front of us. So let's find out what that is. Oh, missed a parentheses. Yeah, both times. One more parentheses. And cosine is 1. Okay, so with that theory in mind, cosine should be, what direction were we moving that box when it was part of the avatar? We moved it X direction. So in this case, cosine should be X direction, and sine should be here. That part we do now know it's correct, because at 0, that should be correct. It may be out of phase sideways. We're going to find out that next. First of all, I believe our avatar name, yeah, my avatar. Okay, so avatar name, we did pass the avatar name correctly, so that's here. Don't have to worry about that anymore. I'm going to mark that time stride. I don't need the direction to be stride unless it's a plus or minus. That's when it matters. I'm going to correct it using this in this degree offset. That's how I'm going to add it to this at some point in time here. Okay, so we have Okay, so it's pointing forward now. No, it's pointing backwards. It's behind me. Fine. It does not want to. And that one's completely off too. Okay, fine. It's pointing backwards. Why is the point behind me? That would mean this is a negative number minus that. Now it should be in front of me. Okay, I'm just getting it to point in the right direction first, and as you can see now, nope, it's still pointing behind me. Why is it behind me? I should have been able to release or reverse this by that. I can even make it more obvious. Let's make this 10. Yep, it's definitely, I'm not confusing the two ends. It's definitely creating it way back here instead of in front of it. So if cosine is backwards, I should, like I said, this should make a difference here. Why is it, is the parse float always coming up positive? No, that shouldn't be the case. Let's just take that off there, because that would be an issue if, well, if it's an issue, it's an issue. Let me do that for the moment. We don't need to parse a float. I just need to see it work. Nope, see, it went negative. Okay, so math cosine comes up negative, or comes up, yeah, negative. Is it? If I turn, does it stay behind me? Nope. It is always facing, it's backwards. Okay, there's something else wrong. Let's fix that part first. I think it would be a minus on one of these two that correct that. And that's the first part I need to make sure I'm straight on. See, because I had to do a negative arc tangent to get the correct angle as I rotate around in a circle. So if that's the case, one of the two values is a negative. And so there it is. Let's see. Now I've got it. That's what it was. It was altering it by the negative value of that. So as I walk forward, each time that's always forward now. Okay, so if that's the correct direction now, so that does that, I should be able to get different directions based on a degree offset. I'll do that in just a minute. Okay, so the last part of this is over here. I took that direction and I'm checking this ray based on that direction, but I did not make my movement based on that direction. So if I take this, which was avatar rotation sign, it was the exact same thing before, times the stride, times a gravity, and that. Okay, so if I do calculate move direction, I should be able to calculate the direction with the move direction with the whole thing, and the only thing I actually need is to make the move at the end. So this whole piece can move to a function. Make sense? Okay, I'm going to continue this. I'm going to take refill the cup one more time. Yeah. Going to refill the cup and I will be right back. So give me just a couple minutes and I'll be back and we're going to keep on working on this. Okay, here we go again. If I want to get move, let's create a function that does that. It's going to be based on this one. So we're going to say instead direction vector, copy that, and get move vector. It's going to be source. We're going to tell it what direction we want to move. That makes sense. And then we have the direction. This one's going to actually encompass everything we already did, but it's also going to make the move. So we have direction. Now move is going to be, get move vector. The only thing we really need to know is the stride. Because I should be able to do all of this in this function, which will cut us out from having to do it a bunch of different times here, which is what we've chosen to do, so what I've done so far. You notice how I always blame whoever's watching? I said we chose this. It's basically me, and I blame myself, and I'm the one who created to do it that way, and yeah. Okay, so I want to take this stuff and I'm going to move it into here. Basically, this is what we're going to teach this thing to do. And we already have a direction, which is this. We're going to figure out what the move path is, and then we're going to return the move here. So that's what we're going to do in here. To do it, we need to know the stride. So we will take, pass the stride with the rest of this. This is going to be get move vector. Get directional vector, get move vector. And it's going to include the direction degree offset and the stride. That way we know exactly what we're doing. We can get the let's take these and move them over here. Var move equals WalkTheWeb that, and then we're putting in these three values, which in this case are the avatar name, the degree offset is 0, we're going straight forward, and the stride is, I'm going to make that a Z stride just because we're fixing things. We'll fix some naming convention as we go. So Z stride gets passed into there. We find out the move, and then we make the move. Okay. So we have Z stride, which I'm going to now replace anywhere we said stride before because I want to make sure we're catching them all. We have this one, oops, missed that one altogether, that one, and before I do the last one, I always glance to see if there's no one. Yeah, I'm not even going to use that one, but it's good to know. And this is the last one of these. This is no longer needed because we already got that direction thing working. And direction is this, so we don't have to recalculate that anymore. We already know the direction right here. And the direction is going to be passed in here to check the ray of wherever we're looking. And it's going to tell us from that position to there, it's going to find out a ray, and it's going to say if they were running into anything within the next 50, that's a long distance. We'll make it shorter later on. We don't want him floating off because he's too far away from something. Chances are we're only going to need that to be about 10 by the time we're done. If you're not that close within it, then it's fine. You'll still get the steps to work. Then you pick with the ray, you check the hit with the pick mesh. We look to see if it did hit something. If the distance is less than 2, then we're going to turn off gravity so that it can actually go upward. Now, everywhere that it says, okay, we have source, we need that to replace everywhere that was looking at avatar, because that is our source we're working with. My voice is getting hoarse. Yeesh. Okay, that takes care of the source. Now we know the move, and we can tell it that in our response. We're going to move here is, let's see, we're going to change this direction. We're going to call that bar there. And we're going to change move to here so that we get a global version of it. And we're going to return the move direction. We should call it Z move. Change it there, there, and there. Okay, based on this, we should get the move direction correct, and we should be able to move. So let's see if we get it. Okay, moving forward, and it's still trying to move the wrong direction, but that's besides our point. Okay, so it's still trying to go left when, oh, I know why. Because we did not fix the move direction here the way we did when we fixed the direction math and a negative sign. So our x value is this, which is cosine, a positive cosine. So we need a positive cosine here. We need positive cosine there, and we need a negative sign here. So that's going to be negative sign, and that's what's going to be there. Okay, now we should have, I'm suspecting that we're going in the right direction now for forward. Just getting all of our directions straight. What I did was I've changed the direction of what he's doing, and now we need to get all of the coordinate system working in the right direction for where he's at. And look, we're moving forward again. Yay! That's a good sign. We're moving forward no matter where he goes. Okay, we've accomplished it. And now that we have that, I'm going to be just setting up the rest of these items so that, you know, like backwards is wrong, of course. If I tell it to strafe right, it's going wrong way. Strafe left is wrong way. The only thing that's working right now is rotation and forward so far. But you can see how we're getting the right things in place. And now we're telling it the proper way to work. So we should be able to get it to do everything based on this formula. And the good news is, now that we've written a function that does this, at any time, if I want to know a vector of the direction he moves or is facing, or any box is facing, we can get a directional vector just by clicking on, you know, that, tell it the source, and you can also tell an offset. So if you want to know, well, we'll correct that, but you can tell it if it's off 90 degrees or if it's whatever. You're going to be able to just rotate and do those. But the good news is you're going to be able to do this, get a directional vector at any time, and your move vector based on this. So that will tell us what direction we want to move, and now we only have to tell it how strong we want to move and what direction, degree offset, we're going to do. So if we want to move 180 degrees, that's moving backwards. 90 degrees, negative 90. We're going to be able to just define that as easy as telling it what degrees we're moving from the direction we're facing. Okay, so that takes care of that, and we've done a pretty complete section today of making him move around and everything and getting the offset corrected straight. We had a problem with that before. Now the good news is if we want to match an angle of something, all we have to do is say, The direction where our avatar is now rotated 90 degrees so that it fixed the angle he was facing in the way that we move. So that makes it definitely a lot better for us. And we'll keep on correcting the different pieces that are related to that. But I want to thank you for joining me today. And we'll definitely keep on going with this. And Exiled, I will be making you a website. If you like, I can do 3d.exiled.walktheweb.org. I'll set that up for you. If you give me a domain name, just message me and give me a domain name. I'll make it that instead. But otherwise, I'll set it up as that. So, good thing. Great day today. Got another piece done. We're able to straighten out this angle of our person, which is going to make it a lot easier to program, like when we're working with telling it to move to a point and turn to a point or whatever. It's going to be so much easier to work with now because the general math is going to basically work with it. Okay. With that said, we're going to call it a day here, and I will see you again real soon. Thank you for watching.